everybody? Somebody give me a 5 for 5 and we will roll out. So what's crack-a-lackin', peeps? Hope you guys are having a good past couple start to your days, start to your week. I am sorry I didn't stream yesterday, but I had severe computer issues. I actually was setting up for a live stream and my disk space went to 100 for no reason. Went from like 5 to 100, like snap of your finger. If anybody knows anything about computers, that will absolutely kill the speed of your computer to the point where you can access stuff, but it takes about 5 minutes to load a web page. So, yeah, that wasn't going to happen. So I had to do some things and work and change some things around. What was this? This case, everybody's wondering what it was. Believe it or not, my automatic Windows updater was on, and I usually leave it on, but for some reason it was taking a long time to download the update in the background. So while I was trying to go live, it was trying to download at the same time. And anybody that knows anything about computers, that kills your bandwidth and you are done. You're not going to be doing nothing until you just let it download. So once it did that, yeah, about 2 o'clock in the morning, I was able to start messing with that computer again. So anyway, we are here on some not so pressing news, but some just some interesting things happening. Obviously, I'm sure you guys seen the internet outages. That's a big story going on. I don't think it has anything to do with the sun, because nothing was going on at that time. I'll just put that straight on out. We weren't getting hit, and how can I say that? Let me show you. This is the Discover. This is our data we look at for space weather. Now listen what I'm going to say here. We did start taking some hits back here, okay? But in my opinion, it wasn't strong enough to do anything like internet outages. I don't know what caused the internet outages. I'm not going to sit here and try to speculate. It's just not what I do. Because frankly, everybody's going to have, well, they're just like one of those things we all have, right? Everybody's got one. So I'll just leave it at that. You guys can fill in the blanks, the adults in the room, I guess. But that's what was happening. And so we can look at space weather. So if you guys ever question whether or not something is being caused by, geomagnetic activity, basically space weather, a CME or a flare or whatever we're talking about, this is the first place I come. If you see, like, this is the density right here of the space of solar wind, okay? Now, that'll increase with the CME, right? So, if it's consistent like this is, and then all of a sudden, oops, man, I did that last time. Daggone it. Let's just reload it. Okay, so, if it all of a sudden just changes, then obviously something has impacted our magnetic field, our magnetopause, okay? So you got to try to figure out what that is. Now, I want you to notice that even though we were pretty consistent here, right? Now, a data point on here is a dot. This is what I call popcorn, and that's just something I've kind of coined, I guess. When you start seeing that popcorn stuff, that means that something is not normal or is not ambient conditions, okay? But as you can see, it says right? So it means a data point is what it means is it's fluctuating in a more than normal way, right? But notice how everything dropped instead of going up. So given that, we could still be like, sometimes you get a flushing effect from solar wind speed. It'll come in here, it'll hit fast, but what it does is it drops your density down. Because it's moving fast, it'll grab it and flush it right on out the back. So your density just drops. But the key factor here, guys, is the BZ. Always the BZ, I'm going to say it till I'm blue in the face every video. You got to look for the -6, okay? When the BZ is in a negative position, we couple to the sun's magnetic line. And what that means is we couple to, we become one, and it just flows in. Okay, so the more negative we are, the more coupled our lines become with the sun, basically becoming one circuit magnetically, and it just starts sucking it in. And that's what happens. That's why this is so important. We can get huge hits, but if our BZ is in the positive, in other words, we're not coupled to the sun very well, we're going to deflect it like crazy. Our magnetic field does it all the time. And I also want to address something here too. I'm not going to go into a big explanation about this, but anybody that was here on my last live stream, we were talking about at the end of the stream. I can't remember who had the question, but we were talking about what how the sun does this and does that. And he was questioning the laws of the second law of thermodynamics and how the sun breaks that. I'm not going to get into that subject right now. But he was also, well, how does all these things miss the earth all the time? They don't. First off, okay? Just because we don't talk about them doesn't mean that we're not getting hit. We get hit with small CMEs and an increase in solar wind every day. Every day. There's flares every day. Now, I can show you that right here. Anytime you see a little boop, 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 right here, that's a flare. That's X-ray hitting our planet. Okay? So the fact that we are getting hit, we just aren't getting hit with the big ones all the time. Thank God. That's what I'll say to that. And I'll just leave that alone. We can go into, the cone of it. Things, the CMEs spread out as the further out they go. It matters. All that matters. Okay? So we'll just leave it at that. Now, the twin filament thing I was talking about, I want you guys to check this out. This is really cool. I've never seen this like this. This is like synchronized swimming, and I am not even kidding. This is one of the oddest things I have ever seen since I've been doing this. And it's not like bad odd either, okay? Hey, Mary. Hey guys, please share it out for me if you would. Again, I'm kind of going a little bit earlier than what I normally do, but I'm here. Hit that like button for me if you could. Super chats are turned on if anybody wants to support that way. I want to say thanks to Aaron again. He hit me with the super thanks the other day. I tell you, and Linda and Schaefer Girl and everybody else, everybody that comes back and leaves a comment, I can't tell you how much I appreciate that. Even if it's a little, just, hi, how you doing? Hey, liked the video, or hey, hated the video. Those kinds of things push the video out, okay? So, and I hope you guys appreciate that I'm getting to space weather right at the beginning, too. And that's what I'm going to do from now on. So, that's why I've kind of not really looked at the chat till just now. Hey, Ripper. Good to see you guys. Hey, Butterfly. Gunslinger. Hey, Gunslinger will call me out in the comment section, by the way, too. He'll just flat say squirrel right in the comment section. And I love it. Anyway, so let's check this out. Now, you're going to see a filament erupt here. Well, let me do this first. I want you guys to check it out here on the 304. This is SDO, and it's from our perspective. It's in the satellites in geosynchronistic orbit. I am not going to explain what that is today. So, it stays over the same part of our planet all the time, but it's always looking at the sun. I'll just leave it at that. So here's a filament. We got lots of filaments on the sun right now. Wherever see these little dark shadows, and there seems to be just as many on the backside. And when obviously we can't see that, but it seems to be that way because the eruptions we've had lately are coming from filaments. They haven't been coming from just like a flare that will produce an eruption, which becomes a CME. But check out this filament here, and this is significant in its own right, okay? Now you can see that's pretty eruptive, right? I'm going to go ahead and just zoom in a little bit more for you guys. And it is, it's pretty impressive. You know, that's a pretty decent sized filament, and it is kind of hard to gauge exactly what we would be calling, you know, kind of saying how powerful something is here, because the sun's the background. It kind of camouflages how dense this is. We'll take a look at seeds here in a minute, and we get a chance to see it, see how dense it is. But this is not going to hit Earth, okay? This is going to go way far north of Earth. Just because if you look at it, it's kind of horizontal. So when it breaks and it's, you know, going that direction. Now, if this was kind of more vertical, kind of like this, in this same spot, but it would be vertical, we would have a chance of that hitting us because of the way it kind of just flicks out, right? But this is a more horizontal eruption, and it's significant. I mean, it's very dense, and I'll show it to you on seeds here in a minute. But also, it's real dark right here, too, so you can kind of see it there. But what you don't see in this is why we look at different angstroms. What you don't see is the second filament I'm talking about. You kind of see it peeking up right here. Okay? But you're going to lose it real quick because that eruption flies out, right? So let's go up here to the 171 and check this one out. Let me do that first. And, you know, again, it's going to be right here, but you're going to see one on the backside that looks to be almost the exact shape, and it erupts at the same stinking time. It really is like synchronized swimming. In a second, you'll see what I mean. So let me bring this back. Okay, now check it out. Look, here's this filament, but watch back here too. Let's do this right there. See that? That's crazy. Now, you know, I'm sitting there questioning myself, is that on the backside or not? And there's a chance that it might not be, but it looks like it is, because let me tell you why. It's wider. And, you know, it's really hard to tell, because I was thinking, well, maybe this filament started to erupt and this energy was just kind of hanging here. Well, we would see it here then. That's an awful far way away to, like, say this is just kind of the same signature. It's not. I do think this is on the backside, or at least right there on the pole region of the sun. But look how similar that is. I mean, it almost breaks at the same point. Now, you see how wide it is over here? And that's why I don't think that it's the same filament. I mean, it really is wide back here. I just think it's two separate filaments that erupted at the same time. One on the front side and one on the back. And, you know, again, I do think it's on the back. I think it's just over the edge there. But regardless, even if it was right on the northern hemisphere, north pole of the sun, it's still interesting that these are popping at the same time. So if I keep going forward here, you see how that fell back, and then you're still seeing energy hang out from that other one. All right. But I just thought that was extremely, you know, again, it is a significant eruption, but it was, you know, synchronized with something on the backside too. Now I'm going to take you down here and show you the 211, because we don't usually get a chance to see filaments all that great when we're talking about the 211. This one shows up, and it shows up pretty well. It's not unheard of. I'm just saying we don't usually go to this one to look at filaments. So you can kind of see it building right here. That's a coronal hole too. We may connect to that. If we do, it won't be much of anything. I wouldn't think. So check it out. Now this right here shows you exactly how explosive it was in the corona of the sun. It's pretty powerful. It looks like a pretty good blast here. Okay. So wham. See it all just. And this is also normal, okay? You see what happened there? It erupted, and then you see the arcs show up, the magnetic arcs here. These are magnetic connection lines that just show the arcs, right? And it's all that energy traveling on those connection lines. So it is a pretty decent pop there, okay? So I don't know, you know, whatever you want to say that means. It just is what it is. I don't think, like I said, guys, that's not going to hit us. So, if we go down here, see if we can't get to Well, there's the 94 angstrom. I'm going to back out and show you this one because we can look at the flares on this one. I like looking at the flares on the 94. If I'm looking for flares, I'll go to the 94 angstrom or the 131. Usually both, but for what we're doing here, I'm just going to show you the 94. And that's just a part of our light spectrum, guys, that we can't see with our eyes. That's what that 94 angstrom is. Okay, you see how it's popping over there? Now, we even seen that filament erupt. See? You can barely see it. See how it ain't so pronounced? And that's why we look at different angstroms. Okay, but we're getting flares from over here. We had a radio blackout from an M flare over here. Okay, that's why that's in my title. Because that did happen. I'll show it to you. I think it was right there. See that? A little signature right there. That's, and again, I can't tell. It looks like it's occulted a little bit, which means it's behind the limb of the sun. It's being blocked a little bit from the sun itself. So that came in at like a low M-class flare. So most likely it's stronger than that because the sun actually blocks some of the X-ray from getting to us. It wasn't like any kind of massive eruption over here. It was just something that was, it was a flare. It caused a radio blackout. X-rays go out in all directions, pretty much evenly. Okay? It's basically light, it's radiation, it's light, all that stuff we talk about. So it doesn't have a typical direction. We get M flares. If it's on the front side of the sun looking at us at all, and it flares, we get radio blackouts from that. It doesn't matter where it's at. We get radio blackouts from flares that happen just over the limb on the backside. So that tells you right there that it really does go out in all directions. So yeah. Okay. Now, let's see here. So this is where all the sunspots are right now. We got a few, but they don't look to be too concerning. Okay. And what I mean by concerning is they're not intermixing. They don't look like really unstable yet. And they are transversing. Now we got the ones coming from the backside again. Our old friend over here, the one that got hyperactive a few weeks back, that gave us X flares, is getting ready to come back on the front side of the sun. So be looking for that. And we also had we were looking for a possible geomagnetic storm today, a low level one from a possible glancing blow. I didn't really say much about it. I was going to mention it yesterday, but it wasn't really worth getting all, hey, I need to really get this out. It's not really like that on this particular one. Now, we did get hit. Now, I want to point something out, okay? We are right now, in my opinion, taking some sort of a hit, okay? And I'm gonna show you why. And I'm gonna show you the geoelectric field model that I show you guys all the time. It's acting up right now, and it's not gonna. And that right there, when I seen that, I thought, well, maybe that could have something to do with some internet outages, because it is the geoelectric field at the surface of the Earth. Okay, but it's impacted by geomagnetism, right? So that's geomagnetic storming, which comes from CMEs or an increased solar wind stream, those kind of things, coronal holes. Our BZ right now is in that -6 area, okay? And it's staying there more consistent than what it has for the past day or so. So what that means is we are coupled to the sun right now. And like I said earlier, something was going on back here because stuff started fluctuating. So I started looking, and here's the Magnetosphere tools. And again, guys, this is going to look a little bit more crazier than really what it is. Now, this could be that glancing blow, okay? And that's why I'm bringing it up. This definitely could be that glancing blow. So let me bring this back up here. The sun's off to the left. This is our magnetic field, or our magnetopause. You got your bow shock, right? Now notice how things just don't look like it's moving a whole lot. Now I don't want you guys to think that that's crazy looking. What's going on there is you got really low velocity moving particles. That's why it all kind of went red or yellow. And we did. Right there at the end, you see our bow shock reach out. It will do that, okay? Let me show you what I'm talking about. Okay, our bow shock's right there, right? Now watch what happens. See it push out, and it kind of stays there for a minute? We sense it coming. Our magnetic field kind of senses it coming. And it'll go out in front a little bit. It goes out to meet it, pretty much. You gotta think we're talking about magnetism. Positive and negative attract each other. So that's kind of what I'm saying here. I'm not going to go into detail. But we also get the compression. Because back here, we were kind of hanging out there too. Now watch. We got compressed. Then we get rapid expansion. Right there. Okay? We're compressed. Rapid expansion. So we're kind of losing the battle. And then we win the battle. Lose the battle. Win the battle. Now, this is density, and you're not going to see much more than white on this one. Why? Because the density is low everywhere. Right here. Remember I said it went down? And then this is really, really low dense material. It's not, or particles. I keep saying material. Particles. But that's what it is. It's pretty low. I mean, it really is. It's not, I wouldn't expect it to see like that. And that, we hang out a little bit higher than that. 4 is normal, okay? So when we're up here around 10, I don't get concerned at all. I've seen this take a hit close to 100 before and not even put us into geomagnetic storming. Now, our velocity down here, guys, is low also. That's what's kind of got me wondering what the heck's going on. But I did notice when our BZ went negative 6 over here, see how it kind of shot back up? Now, it ain't very high yet, but it could go higher. Also, the speed started coming up a little bit too, and the temperature seemed to kind of level out. So, we're going to watch this. I don't know exactly what's going to happen, but so check out the geoelectric field. Now, I'm not trying to make a big deal about this. This is going to look probably worse than what it actually is. I almost didn't show it because people like to get a little, I don't know. I don't want to say crazy or anything. Just they get a little fearful, I guess. So, again, this is our geoelectric field at the surface. Now, you're going to see us take a hit. And it's a pretty decent one. And it just started happening. That's what I'm trying to say. So, I don't think this had anything to do with any kind of internet outages. Okay? Obviously, you're seeing that. Now, I've seen us take bigger hits than that. Okay? This is a relatively new model. And again, it's Space Weather's effect, basically, on unnatural electrical components. That's what this thing is trying to show you. And they're using it to kind of gauge things and try to help forecast earthquakes. Because we know space weather affects earthquake, seismic activity, volcanoes, all that. Okay? So, you see what happens here. I mean, we take a pretty decent little blast right there, okay? Now, if you're wondering what the highest color here is, it's white. And that's a lot of white. So, that was at 2200 hours UTC. This just happened. This is happening right now, okay? So, I don't know, but what I will say, we also know that space weather affects our weather here on the planet. Okay? So, geoelectric and geomagnetism, if we're having thunderstorms and stuff like that, and it hits over top of that stuff at the same time, it can intensify it. It will add electrons and things like that to our atmosphere. Electrons is what? Basically lightning, guys. It's just adding extra energy to our atmosphere and to our system that wouldn't necessarily be there. And when it's happening during like what we got going on right now, we got a tornado outbreak going on in case you guys didn't know. Actually, I'm kind of like in the heart of it right here. I'm in Indiana. But I've seen a lot of the storm chasers. They're up towards Illinois right now. By the way, go check out Ryan Hall. You guys probably know who he is. He's the biggest weather guy on the internet. They seem to find tornadoes like crazy, him and his team. It's amazing. They stay live during tornado outbreaks 12, 18, 24 hours at a time. They don't give up. I also want to give a shout out too to like Reed Timmer. I'm not sure if you guys know who he is. He's probably the most famous tornado chaser, at least in my lifetime. Seems like every time he goes out and chases, he sees a tornado. It's amazing. I've never seen anybody have that kind of ability. It's crazy, but it's important work too. Okay, so don't take it lightly. It really is. It's important to have those guys out there getting data, because how else do they forecast it? They got to have the data to know what's going to happen, right? But notice how it's kind of, the stronger stuff's hanging around the more populated areas. Why is that? The biggest reason is more people, more artificial electrical components, right? So that's what that's doing. Okay, some of that's kind of offset like that. I don't know if they're going to try to incorporate population into the models. They may already, but they may end up having to kind of tweak that as this model gets a little bit older. But as we go forward here, you see how it's kind of dying off right now. That's where we're at right now. Okay, so I'm not sure what's going to happen from here, if that thing is going to keep moving or not. But that just confirms this. Okay, and this confirms it also. Okay, so both of these are reacting as we see the data start showing an uptick. Okay, so that's what I'll say to that. Now, okay, let's look at this eruption. Now, this is the other thing is kind of, I thought this was just seeds doing this right now. So I got you here at ISWA, and we do got a few more images, I think. Nope. So I think Soho, the satellite, is having issues. I don't know if, and let me explain. I don't know if it's because of space weather. I can't tell. But if you look here to date, I want you, this is ISWA. Okay, so this image and these images are coming from the same satellite. They're just on two different web pages. Okay, it's the same image, same data. All right. So we look here, and there's that eruption I showed you guys, the twin filaments, right? And then it stops, so you don't get no more data. Now, I thought, well, that's kind of strange. What's going on there? And a lot of times you can go to another website and see the data, right? Well, this one is stopping at the same time. Okay? So, most likely the data from the satellite is being affected. In other words, the satellite's being affected. So it's going to affect anybody getting that data. It's all stopping at the same time. So I don't know why. It could be in safe mode from the hit that we're currently getting. I don't know. This satellite sits 1 million miles closer to the sun than what we are. All right. It's the one I always talk about. Orbits right out in front of us. Always looking at the sun. Okay. But I wanted to point that out too, guys. So, is what it is. Stereo A, though, is not. Stereo A is still producing imaging. So we got, and this is actually from our point of view now. This used to be hanging out 90 degrees, but we don't get a side view anymore. So, but you see how that erupts? Wham. It's like that. Whoop, whoop, whoop. Anyway. So, yeah. But, guys, that's pretty much all I got for you. I'm not going to keep you guys here much longer. Thanks for stopping in, and I'm sorry about the past 2 days. The first day, I just took a day off because I try to take 1 or 2 days off a week, and I try to mix it up a little bit. That way, in case something happens, I can still be here. Now, make no mistake, I will be here if something big happens. I don't care if I'm here 7 days a week. I will always be here when that happens, even if it's just me popping on and saying, hey, this is going on, and then getting off. But this is what I just wanted to give you guys this, and I do apologize for yesterday because I actually, my wife seen me kind of getting a little upset at my computer. It was, I'm just glad I figured it out and wasn't something where I was going to throw my computer in the trash. But anyway, so what I will do is, if anything else new happens, I will be here always. We'll take a look at this running as we kind of exit out here. Now, if anybody's got any questions, fire them in there for me real quick if you would. and I'll take a look and say hi to you guys. Hey, Jerry, Butterfly, Mama, Gunslinger, good to see you. Thanks, Gunslinger. I appreciate you, bud. I really do. Hey, well, thank you, Genius by Birth. Burning Daylight. How big burning would a... Okay, he asked, Burning Daylight asked, how big would a CME need to be to take the grid down? Well, the biggest one that we had in, well, 1989, there was one that hit, and it took out part of Quebec. All right, the big regional area up in Canada went down because of a solar storm. Okay, to take the grid out, that's one of those things that's just out there that is kind of an unknown. All right, and because there's so many factors that play into it, you could have smaller eruptions back to back to back to back to back that could cause the grid down. You could have, if you're talking about just like one big blast, like a Carrington event. I think, matter of fact, I think the Carrington event though was 2, if I remember right. I'll have to go back and look, but it was like an X29 or I can't remember exactly. It was just so high. I don't even know why I haven't committed that to memory. I should know that. Yeah, it's actually kind of embarrassing. I don't know the X size flare that was produced during the Carrington event, and here I am talking about the sun. Yeah, I need to know that, don't I? So I'm gonna have to figure that out. No, I'm just kidding. It was high though. It was in the, I believe it was in the 20s. It might have been like first off, it was hard to tell back in 1859 exactly. Now they were pretty accurate. And also I want to bring this up too. They did find it in the tree rings now too. They didn't think they were going to be able to do so, and they did. They actually found its carbon footprint in the tree rings from the Carrington event. So, you know, we know that actually did affect those things. So, you know, it's telegraph lines and stuff were catching on fire in the operator's hand and everything else, man. I mean, it was a mess. It really was. And it was global. But to give you a clear-cut answer, I can't. I can just tell you it's bigger than anything I've ever been able to show you. Okay? That's what I will say. And also, when it does happen, something like that, because it is a matter of if, it's a matter of when, not a matter of if. When that does happen, I'm probably not going to be out here to be able to tell you. It's probably going to happen so fast that, because the flare hits, it has its own stuff that it causes, communications mainly, and then you get the CME behind it. It's, in like a grid down situation, that's getting here in 12 to 15 hours, if not quicker. So that's what I'm trying to say. We already got a 4-hour lag time in the data we get now that I'm showing you. So, yeah, take that for what it's worth. I really don't have a good answer for you. I can just tell you it would be probably in the X range of, higher than anything I've ever shown. So, wish I had a better answer for you. There's just too many factors there. So, yeah, you're right, Grace. You are when something like that happens, guys, you're going to have to understand. Hey, Bonnie and Soul, good to see you. Hey, Jerry. Hilly's in the house. How many toes does it? Dude, you make me laugh every time. Oh, you're welcome, Bernie. I mean, that's why I ask. I truly do ask that. And I ask that for a reason. If you guys got any questions, I want to be able to answer them. If I don't know the answer, I'll find out. And this is my promise right now. When I come to you guys tomorrow, I will know the X class or the flare range that the Carrington event was. It is something simple as a Google search, but I will say that. I can't remember exactly what it was. I think it was I think it was like 25. Again, I'm not going to sit there and make myself sound more stupid than I already have. So it's embarrassing. That's an embarrassing thing. But listen, I'm not afraid to be embarrassed. I'm not afraid to be wrong. And I'm not afraid to not know something. What I'm afraid of is not telling people the truth. Okay? So that's where I'm at. I'm not going to sit here and tell you I know something when I don't. And I hope you guys can appreciate that, and I know most of you do. Hey, J-Man. Yeah, I'm starting to feel a little bit better. You guys can probably hear it in my voice here. I'm a little bit more upbeat. But, you know, I get asked, this person over here is arguing about this. This person over here is arguing with that person. And it becomes a big, you know, internet drama and all that. I'm on nobody's side. I land right where the truth is. That's the side I'm on. I'm on the side of the truth. I'm on the side of being honest. I'm on the side of all that, and I will be. And even if it means I have to come out here and tell you guys I've got everything I've ever said wrong. If that was actually the case, I would come out and say that. I hope I never have to do something like that, but that's, you know, I've come out and, you know, told you guys when I was wrong before. I do it all the time. But I can promise you this too. I won't be wrong about that specific thing again. That's how I learn. I won't forget it. And so thank you guys for taking that journey with me and allowing me to be wrong sometimes. I got a lot of things wrong early on. And I now understand what's going on as far as what I'm looking at with the models, the data, all that kind of stuff. I got a better understanding. I'm continually learning from people way higher than me in a pay grade. You know, Tamitha Scove, Ben Davidson, and everybody else that's out there that's doing way more and can get way more in depth than I can. I listen to everybody. So just know that. All right, guys. God bless. Yahusha saves. And you can drink this Kool-Aid.